Hello, let's continue our Sudoku adventure with Serendipity by Randall. So I'm told that this is kind of an entry-level killer for people who are new to killers. So if you're experienced, you should have no problem at all. So I'm going to take my time solving it to make sure that I explain all of the kind of basics that you might need for killers. But this is still a live solve, so I don't know exactly what the solve is, but given the note that Randall left, that's going to be my approach today. So don't be daunted by the length of the video. I'm probably going to be spending just a little bit more time explaining than I usually do. All right, so let's carefully go over the rules. So we do have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these dotted lines in the grid. These are called cages, and they cage certain cells. So these two cells are caged by these dotted lines. These two are caged by these dotted lines. So the digits in a cage sum to the value in the top left. So here this value is 6, so these two need to sum to 6. So for example, we could put 2 and 4 there. 2 plus 4 is 6. That's good. We can't do 3, 4. That adds to 7. That would break the cage. But we could do, say, 1, 5 or 5, 1. Order doesn't matter as long as they sum to that value. And that's it. Normally there's a rule that digits can't repeat in a cage, but Sudoku is already doing that for us in all these dominoes. So that rule's just been omitted to avoid confusion. All right. And that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So specifically, it looks like this puzzle's focused on what we call dominoes, 2-cell cages. And this works for any cage, but especially works well for dominoes. Is first thing you want to think about is in the size Sudoku you're playing. So in this case, we're playing a 6x6. What is the minimum sum and what is the maximum sum? Well, I would say the minimum sum in a cage, let's just pick this one as an example. The minimum sum would be if I put a 1 and a 2 in it. If there's a 1 and a 2 in this cage, then they add to 3. So our minimum sum is 3. And then what's our maximum sum? Well, the two biggest digits I can put in here, without repeating anything, is 5 and 6, and that sums to 11. So whenever you're at the minimum or maximum sum, those digits are forced. So for example, we have an 11 cage here, and we know that there's only one way to add to 11 because we have to use the two biggest digits we can to just reach 11. And so this 11 cage, we don't know the order, but we know that it has a 5 and a 6 in it, one each. All right, the rest of these are like 6s and 5s, so we can't quite say this is exactly what goes in them. But for sums that are pretty close to the min or max, first of all, a 4 cage, if we had one, like if we had a 4 cage, there's still only one way to add to it, because one way to think about it, and this is a really nice generic way to think about cages, is 1, 2 are the two smallest digits I can put. That adds to 3. So if I want to add to 4, I need to add 1 to one of my digits. That's the only way to increase it by 1. If I try to add 1 to the 1, I end up with 2 plus 2, which repeats the 2. So even though that does add to 4, I'm not allowed to do it. So the only digit I can add 1 to is the 2, making it 1, 3, meaning there is only one way that I can add to 4 as well. But now if I want to add to 5, I need to add 1 to this. And notice there's a gap. They're both odd digits. So I can increase the 1 by 1 to make 2, 3. Or I can increase the 3 by 1 to make 1, 4. So the 5 and also the 6 have one way to add to them. And so we know that there's only two ways to add to 5 and 6. So since we know there's only 2 ways to add to 5 and 6, we can do a little trick here where all these 6s kind of see each other. What do I mean by that? Well, let's just play through, I wouldn't normally do this, but let's just play through a scenario. Let's say that this 6 ended up 1, 5. Could this 6 also be 1, 5? Well, I could put a 1 here, but then I'd have to put a 5 here, and I'd repeat the 5. Or I could put a 5 here, and then I'd have to put a 1 here, and I'd repeat the 1. So actually, because this cell can't be 1 or 5, I'm not allowed to make this 6 add as 1, 5. So there's only one option for it, which is 2, 4. And I'm just picking an order here. Obviously, they could go in the other order, but I'm doing this to demonstrate. And now this cell here can't be 2 or 4. So we know the way we cannot add to 6 with 2 plus 4 because we can't put any of those digits here. Again, if this were 4, this would be 2, it would repeat the 2. And if this were 2, this would be 4, and it would repeat the 4. So this has to be 1, 5 again, and I'll just pick an order. And so now again, this cell here sees both 1 and 5. So basically this domino here staring at this cell prevents this 6 from being 1, 5. So it has to be 2, 4. And so we don't know, though, that this is 1, 5. This could easily be 2, 4, and then these would resolve the other way. And again, I'm just picking numbers. The order could be different. Doesn't matter. And so what I'm going to do is I'm going to color this green. And I'm going to say whatever this ends up being, if it's 1, 5, or 2, 4, that's going to be the green digits. So it's the green way that we're adding to 6. We're just coloring it. There's only one other way to add to 6, and we're going to call that the purple way to add to 6. So this is the green way, and this is the purple way. And so one thing, another thing with 6x6s that's always very useful to think about is that 6x6s have what's called roping, where whatever these 3 digits are, because each box has one of each digit, those 3 digits need to end up down here. So these 3 digits end up down here. It's the same 3 digits, but the order can be mixed up because they need to go in this box somewhere and they can't repeat in the row. So these match these and these match these. So that means these 2 green digits have to end up in this box somewhere. And we know they aren't the purple digits by definition. And so the 2 green digits need to go here. And then these green digits are telling us these green digits go here. And so now what I can do is I can, well, there's 2 more digits that aren't green or purple. I could call those orange if I wanted to. I wonder if I should. Let's not for now. Let's not introduce orange, but okay. So here's another trick we can do, which is we have 2 9 cages here, and there are only 2 ways to add to 9. But let's say we wanted to analyze this in a different way, because I think this is a good opportunity to talk about that, which is that an entire row, column, or box, we know it has 1 through 6 once each. So we know the sum of an entire row. The sum of an entire row is 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's a triangle number, and it's 21. And so if we know the entire row adds to 21, and we know these 2 add to 9 and these 2 add to 9, then what do these 2 add to? Well, it's going to be 21 minus 18. And if we do 21 minus 18, we get 3. And so these 2, it's kind of like having an invisible 3 cage here. These 2 add to 3. Remember, that's the minimum. We need to put 1, 2 there. Another way you could think about that is that one way to add to 9 is 3, 6. The other way is 4, 5. So that's missing the 1 and 2, which have to go there. All right. Let's see. What's a nice thing? So now I'm going to introduce the concept of 2 dominoes that see each other, that like 2 dominoes that share a row in this case, that are 1 apart in sum. They always kind of restrict each other. But I think an easier way to think about this 5, 6. Let's talk about 2 ways to think about it. Let's do the hard way first. So you can often case checking it is the easiest way, especially for something like 5 and 6, where 5 can be 1, 4, or it can be 2, 3, and 6 can be 1, 5, or 2, 4. Now, the key here is thinking about the 2, 4 option for the 6, because the 2, 4 option for the 6 removes 2 and 4 from this 5 cage, and guess what? 1 plus 3 does not equal 5. So we cannot do 2, 4, and so this 6 can only be 1, 5, making this having to be the 2, 3. So that's forced. Another way to think about that is these forced digits sum to 11. And so we can do this 2 ways. One is just I know that 11 and 4 is 1, 2, 3, 5. It's the only option. We can prove that in the same way we did the dominoes, which is the smallest I could put in these 4 cells is 1, 2, 3, 4, which adds to 10. But I need to get to 11, so I need to add 1 to it. I can't add 1 to the 1, 2, or 3. I'd repeat a digit. So I can only add 1 to the 4, making it 1, 2, 3, 5, making that the only way that I'm adding to 11. Or we can think about the outies. If these add to 11 and the whole row adds to 21, then these 2 add to 10. There's only one way to add to 10, which is 4 plus 6, because it's 1 less than our max of 11 in a domino. Either way, that 4, 6, we know 6 can't go in purple. So this ends up being 4, 6. And this is 4 plus 2 is 6. So we've just proven in a lot of different ways that this green is always 1, 5, and the purple is always 2, 4. And now I don't need the colors anymore, because we have digits to talk about. And so now this is the remaining 2 digits, 2, 3, which does luckily add to 5. And this 2 tells us this is 3 and 2, which tells us this is 1 and 2, which tells us this is 5 and 1, which tells us this is 6 and 5. That makes that 1 and 5. That makes that 1 and 5. And this one makes that 5 and 1. Very nice. So now here we need the 3, 4, and 6. I'll just write that out. That's not a 6. This whole column needs 3, 4. This cell can't be 4 because of the 2, 4 pair here. This has to be the 3, and that's the 4. And now this cell is a 6. That's 3 and 6. So So these dominoes, let's see. Let's think about this 9 cage, right? Remember, it was 3, 6, or 4, 5. There's already a 6 here. So this has to be 4, 5. And that resolves with this 5 here. And this has to be 3, 6, which resolves by this 6. So now these two cells are the 2, 3. This 2, 4 pair tells us that's 3 and 2. And these two cells are the 1, 4. And this 4 tells us that's 1, 4. And so now this cell here is 2 or 4, but it can't be 2. So that's 4, that's 2, that's 4. These 3 cells are 2, 3, 6. The 2 goes here, the 3 goes here, and the 6 goes there. And we're done. And of course, as I said, because I was trying to explore as many properties of killer cages as I could before the puzzle solved, hopefully I did a good job of that. So yeah, those are like the real good basic ways to think about killer cages, while avoiding most case checking. I did go over one way you could case check these dominoes, but you can also think of it as it has to be 1, 2, 3, 5, and there's only one way to distribute that to make add to 5 and 6. Or you can get the 4, 6 pair here, which then gives you the 4, which then tells you that this can't be 2, 4. So lots of ways to kind of accomplish that, but always be suspicious and pay attention to when you have 2 dominoes that share a row, and they're 1 apart from each other in sum. It's always going to be, they're going to eliminate certain combinations from each other. All right, cool. Well, hope you enjoyed that. Thanks, Randall, for the nice intro to killer cages and giving me the opportunity to talk about these strategies. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.